shows C of t, the percentage of full capacity that the battery reaches as a function of time. So percentage time, percentage time. Okay. What is the meaning of the derivative C prime of t? C prime of t is, let me write it down for you. I'm on 13. So this is 13 in 2.8. So C prime of t is the rate of change of percentage of full charge with respect to time. The measurement unit has to be percent per hour, in percent per hour. Let me stop for a second. C prime of t is the rate of change of percentage of full charge with respect to time, measured in two measurement units, percent from the y variable and hour for the x variable. Then part B, sketch the graph of C prime. What does the graph tell you? So if I want to do that, let me look again real quick. It starts at 0. Yes, it does. Okay, perfect. So here's the graph. So this is C of t. And right underneath, exactly under this graph, I will graph C prime of t. Again, it will be an approximation. Everything is an approximation here. So at this point, this is the slope. At this point, this is the tangent, and this is the slope. At this point, this is the tangent, and this is the slope. At this point, this is the tangent, and this is the slope. And at this point, I see something like this. So remember what we discussed with this point. Undefined. Vertical tangent. So I'm going to say that this is 3/1 at this point. 1, 2, 3. At this point, 2/1, because obviously it decreases, right? Still positive. I'm going to say that here is getting closer to 0. Okay. So it's positive, as you see, 3/1, 2/1. I'm going to say 1/1, 1/2/1, maybe 1/3/1. I'm sorry. I meant to write 1 and 2 here. I jumped to writing the slope. Okay, so 3/1, 2/1. For this point, 1/1. For this point, even smaller. For this point, even smaller. For this point, right? So here is the slope, the C prime. Any questions? Anything else you would like to? We still have a little bit of time. So any questions? Any other type of problem? For this point here, it's difficult to see, is it, if it's like this, if you consider it like this, you may be able to find a tangent here. You may say it is defined. So I don't know. You may consider it somewhere here. That's possible, depending on how you see this point. If you see it more like this, then I'll accept a high slope. If you see it like this, then I'll accept an undefined slope. That part is sometimes difficult to tell. But what I'm interested in is that it's obviously decreasing. The function is increasing, but its rate of change is decreasing. From 3 to 2 to 1 to 1/2 to 1/3 and potentially to 0. Good. Any other type of problem that you would like to look at? I lost you guys. Where are you? Any other type of problem? Do you want to do one with a table with a in which we are given all sorts of information about the function and we're asked to graph it? To graph an example? Yes? Okay. So let's take a look. I think we haven't looked at one in 2.8. Let's see if there is one in 2.8. If not, we'll go back. No, let's take a look at 2.7 then. The only important step in those problems is to organize the information. Once you organize the information, sketch the graph of such and such. Did we do one of these? I don't remember. Would you like to choose one or not? We have time.
41 is fine.
Okay. I hope we didn't do 41 before. Okay, 41. Continuous. Okay, the function is continuous. On its domain of -5, 5 specifically. G of 0 is 1. G prime of 0 is 1. G prime of -2 is 0. The limit of g of x as x approaches -5 from the right is infinity. And from the right is infinity, yes. And from the left is 3. X approaches 5 from the left of g of x is 3. Let me check, I copied correctly. It continues on domain, yes. G of 0, 1, yes. G prime of 0 is 1. G prime of -2, and the limit from the left is infinity, and the limit from the right is infinity, the limit from the left is 3. Okay, good. Sorry about that. Okay. So it is clearly stated -5 to 5, and not -5, and not 5. That's the domain. It means at this point, it may have a vertical asymptote. You can consider that, because the function is not defined in -5 and 5. So this is done. This one, g of 0, is 1. That's done. Now, g prime of x. G prime of 0 is 1. Okay, that's done. G prime of -2 is 0. That's done. -5 from the right, that's infinity. -5 from the right, that's infinity. Done. 5 from the left is 3. Good. So here is my take on what I see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So obviously this is the case. X equals -5. At -2, the derivative is 0, which means -2 derivative 0. This point is a max or a min. We know that for now already, that at -2, that's -2, the function, so it's coming from positive infinity, but it has a max or a min, so if it comes from positive infinity, the slope here is 0. At 0 is 1, but also the slope is 1. So here the slope is 0, as discussed. So in order to bring the slope to +1, I have to do something here. So now the slope is 1. So 0, 1 is a point, and also the slope is 1, because the derivative gives us the slope of the tangent. The slope of the tangent here is 1. The slope of the tangent here is 0. And then, so this is 5. So, and the function continues to 3. But it continues to 3 like this. Why? Because it's the limit. It doesn't say that g of 5 is 3. No, the function is not defined at 5. So this cannot be a full point. It only says that the limit from the left of 5 is 3. But specifically it says the function is not defined at 5 and is not defined. So here I'm going to erase this, although you can put it in if you want, but they're telling us that the limit is 3. So I'm going to remove this. There is no need for this, because the limit from the left is 3. I came up with this idea before I put in the last piece. So this is our example of f of x. So infinity, at -2, the slope is 0. At 0, 1, the slope is 1. And then the limit is 3 here. So 1, 2, 3.